So let me just show you one example of how you actually create horizontal currents and fluids. Okay? So what happens if you start an experiment with a horizontal density contrast? And this is shown here. You look from the side, you have a tank. On one side is heavy water, on the other side is light water. So how do you create heavy water? It can be colder, okay, or it can be saltier compared to the other water. You can also put some dye in there into that water, and then you can see what actually happens. What we also do is we consider a time scale which are not influenced by the Earth rotation. What that means is if the process only lasts for, say, a minute or an hour, it's not influenced by the Earth rotation. For this, you need a time scale of a day or longer. And then the Coriolis force kicks in, and the world looks totally different, and the process looks totally different. Okay? And I want to show you this process just with a computer-based simulation. You start an experiment like this, and then you just look at how does it look like in the simulation. This is how it looks like. Okay, you get a movement of the red, denser water, and it propagates along the tank. This one's actually a closed tank. You look from the side, and it jumps up on the right side of the tank or so. So it's over 30 minutes, and you can see that there is some mixing and all that stuff. So you can do interesting simulations with computer-based models. Okay? And these type of features are called density-driven flows. The world is totally different if a process is influenced by the Earth rotation, and we'll come to that on the next slide.